Alright, so this question got sent to me by one of my followers, and it's an organic question, and they struggled in particular with part AI. So they said the rest of the question was quite easy, and after having looked through it, it was very easy. So I'm not going to go through that, but I would understand why people would find part AI difficult. And the simple reason for that is because the mechanism that is being showed, so of course this is a mechanism question, is really unfamiliar. It kind of looks really weird, really long, and usually within A level you kind of get questioned about mechanisms you already know and you've memorized, and you can just kind of write them down, draw them out really quickly and get those marks. But this is not the case for this one. So I decided I might as well make a video on it. So pause it, have a go, and see if you can get it right after I've shown you how to do it. Okay, so firstly, let's just read the question. Just make sure we understand exactly the reaction that's going on. So we have ethyl ethanoate, which is drawn here, and then it stated that one method for the formation of ethyl ethanoate is a reaction between ethanol and ethanoic acid, which is catalyzed by hydrogen ions. Then an incomplete simplified mechanism for this reaction is shown. Add curly arrows and relevant lone pairs of electrons to complete the mechanism. So as you can see, the reaction is an esterification reaction between a carboxylic acid and an alcohol. So that's easy enough, but it wants you to actually draw the mechanism, which is the hard part. So let's get started. So in terms of how I would go about these types of questions is, if it's multi-step, there's lots of products or lots of intermediates before you get to the final product, I would label each product that I can see. So I'd label this as 1, label this as 2, this is 3, and then this being the fourth final product. And then after that, I would kind of see the differences or spot the differences between like the two closest intermediates. So for example, the difference between the first and the second, the differences between the second and the third, and then finally the differences between the third and the fourth. So let's just do that, and that's how we're gonna break it down step by step in order to solve the question. Okay, so in terms of the differences between the first and the second one, all I can really notice here, to be honest, is the fact that there's an extra hydrogen attached to the oxygen here. So, and that's it really, that's all there is to it. So using our knowledge of oxygen, we should know that there's a lone pair here when it's bonded to two different groups, which means that if there's a lone pair, these lone pairs can directly attack this positive hydrogen atom here to directly form this bond. And that's it. That's the first mark. That's all we need to kind of note down with that, because that's the only difference. So that's the first mark done already. Now, the second one is slightly harder. So the difference between the second and the third. So we can notice that this group here has kind of replaced this water group here, right? So we need to kind of find out how that's happened. So the first thing we should notice is this carbonyl group here. And if you have revised carbonyls, you would know that the oxygen is more electronegative, of course. So that would be delta negative with a slightly negative charge. And then the carbon would be slightly positive. So that's the first thing. And the question doesn't require you to write that down, but I think it's really useful too, just to kind of show the examiner that you know what you're on about, and also just to help you as well, to help you kind of reason through it. So I think it's really useful. The next thing is, again, we have an oxygen bonded to two groups. So again, there would be another lone pair here. Now, if you can notice that between the second and the third, we also have this extra water group. And this water group has come directly from this, which is also a water group. So it's essentially a substitution reaction. This group has kind of directly substituted for this water group here. So we can use that, and we can say that because this carbon has a slightly positive charge, the lone pair can attack this carbon. And then, of course, this group here has to break this carbon to oxygen in order to form this water molecule. So we can directly say that the bond goes into the oxygen, and you can also kind of reinforce that because this oxygen is positive, which means it needs some form of electrons to feed into it in order to make that charge neutral. So that's like another kind of bit of evidence that we can use to show that that's right. And that's the second step. That's done now. Perfect. Now, the difference between the third and the fourth product. So all I can really see here is the fact that this oxygen is no longer positive here. and then the fact that the hydrogen is cancelled, so there's no hydrogen bonded to the oxygen. So that can only really mean one thing, which is that these electrons in the hydrogen break off, so the bond breaks, and the electrons feed into the oxygen to not only make it kind of neutrally charged, but also to break off that hydrogen, because as you can see, that hydrogen isn't present here. And you'll find that that's everything. So that's 4 out of 4 marks. If you got those, that's really good. So I hope that was useful for you. Just kind of make sure you remember to break it down step by step. Don't just look at it and give up just because it's such a big mechanism that you've never seen before. Just try to break it down. Use your common sense. Use your knowledge of carbonyls and your knowledge of kind of lone pairs and how they work to answer questions like these. So I'm not going to go through the rest of the question, like I said, just because I believe it's really easy and it'll be a waste of time. But make sure you guys like, follow, comment, share my videos as well. And yeah.